guys, welcome back to the room. I have my rainbow cup with rainbow straw just for you because I needed coffee this morning. We are going to be doing solving radical equations. So this is 11.5. We are going to look at those radicals. We're still kind of working with that. Our first step, remember any time that you square one of these, it just gets rid of that radical symbol, right? So I'm going to work with the first step. Let's say I have the square root of x, and that equals 6. So what I'm doing is, what would go in there that if I were to take the square root of it, it would equal 6, okay? I think I said x a second ago, it's fine. So if I square both sides, that's going to be the best way to do it. You may be able to go, okay, I know if I put 36 in there and I take the square root of 36, it's going to equal 6. That's fine. But we're going to go ahead and square both sides, because whatever you do on one side of the equal sign, you have to do on the other. So I square both sides. That is going to tell me that radical symbol in the square, the exponent is going to cancel each other out. So then I'm left with x. Now 6 squared is 36. Again, you probably could have figured that out. Let's do another one like that. And we'll get there. So let's say I have the square root of x equals 9. Again, I square both sides. So I take this whole thing, square both sides. That is going to cancel out. So I'm just left with x. 9 squared is 81. So I just solved for x. Okay. Let's say it gets a little bit harder though. So let's say I have something like 9 equals the square root of 27x. My first thing I want to check is the radical symbol has to be by itself. So that's the first thing I want to double check. Is the radical symbol by itself? Yes, because everything there is inside of the radical. If there was something being added to it or subtracted from it, then I would have to move it to the other side. But right now I have the radical symbol on one side of the equal sign by itself. So I'm going to square this side, square this side. All it does on this side is gets rid of that radical symbol. So then I'm left with 27x, and then 9 squared is 81. Now I can solve for x. So I divide both sides by 27, divide both sides by 27. I know I can simplify that, so I'm going to be left with x over here. If I take both of these and divide by 9, that'd be 9 over 3. So it looks like I can divide both by 27. I should put that over there, but whatever. 81 divided by 27 is 3. 27 divided by 1, or 27 divided by 27 is 1. So I get x equals 3 over 1. Can I leave it like that? No, we need to simplify. So I'd say x equals 3. We went ahead and solved that way. Let's go ahead and do one more like this, and then we're going to take it a step farther. Let's say I have the square root of x over 3 equals 2. Now, going back to previous lessons, if I can simplify this inside the radical symbol, go ahead and try it. If not, which 3 is a prime number, I can't simplify it, so I'm going to take both sides and again, square both sides. This just cancels out the radical symbol and leaves me with exactly what is inside that radical symbol. 2 squared is going to give me 4. Now I still have to solve for that x. So x divided by 3 means I'm going to multiply both sides by 3, multiply by 3, and I'm going to get the x equals 12. Not too bad so far, right? So let's go ahead and we will try a step farther. So let's say I have the square root of x plus 3 equals 7. Okay? Is the radical symbol by itself? That's my first step to check. No, it's not. So I have to get that radical by itself first. These are going to cancel out, so I get the square root of x equals 4. Now I can go back to what I was just doing a second ago, where I square both sides, the radical symbol and the square cancel each other out. I'm left with x equals 16. I can't forget to square this side and that side. I cannot just leave it as the square root of x equals 4, because that's not solving for x. We want to solve for x, okay? Well, let's try another one. Let's say I have the square root of x minus 5 equals 4. Is a radical symbol by itself? Yes. There's nothing additional or take it away from the radical symbol, everything in there is inside that radical. So I can still do that squaring and squaring. That cancels that out, so I'm left with x minus 5 over here now. I square the 4 and I get 16. I'm still not done. I have not gotten x. So I need to add 5 to both sides. That will cancel out, and now I have x equals 21. And now we've solved for x. So let's go ahead and try one with this and adding and subtracting. So we will take another one. Let's say I have, that one doesn't do it, okay. Square root of 3x plus 7, and then it's minus 1 equals 3. Is the radical symbol by itself? No. So I need to go ahead and get rid of this minus 1, which means that I do the opposite, add 1. Those will cancel out. Now I have the square root of 3x plus 7 equals 4. Now I have a radical symbol by itself. I have the 4 by itself, so I'm going to go ahead and square both sides to get rid of that radical symbol. And then left with 3x plus 7 equals 16. I still need to solve for x, so I'm going to subtract 7, and I get 3x equals 9. Divide both sides by 3, and I get that x equals 3. Now, if we wanted to double check it, we could plug it back up in here. So let's say the square root of 3 times 3 is 9 plus 7, so the square root of 16 minus 1 equals 3. What's the square root of 16? 4. 4 minus 1 equals 3. Look at that. So we just double checked. That works if I plug it back into the original radical expression or radical equation. Okay, let's say I have something like this. 3 times the square root of x equals 21. Again, I don't have a radical by itself. I have to get it by itself. So in this case, when it's smushed up next to each other, it's multiplying. So I want to divide both sides by 3. Then I'm left with the square root of 3 equals 7. Now I can go back to what I was doing before. Square both sides. That cancels out the radical over here. I get x equals 49. Okay, let's try another one like that. Let's say I have 2 equals the square root of x over 4. Is the radical symbol by itself? No. In this case, it's over 4, which means that we're dividing by 4. So I want to multiply both sides by 4 to get rid of that. Then I have the square root of x left over here. 4 times 2 is 8. Now square both sides, get rid of that radical symbol, and I get 64 equals x, and we've solved for x. Let's go ahead and try one where I have 2 different radical symbols. That one is a little bit harder when we have something like that. So let's say I have the square root of 2x minus 5 minus the square root of 6 equals 0. Now, I have 2 radical symbols, and if I square this, that's going to be all crazy. So let's go ahead and move this to the other side. So then I have one radical, 2x minus 5, equals another radical. This is going to be your hardest step when I have 2 radical symbols within one equation. So I have one equaling another. Now, if I square both sides, when I do that, it's going to get rid of both of those radical symbols. So that one's going to cancel out, and that one's going to cancel out. Now I have 2x minus 5 equals 6. And I'm going back to my basic, just solving for one variable type of equation. So to do that, I add 5. I get 2x equals 11. When I divide by 2, I can leave it as an improper fraction. Just leave it as 11 over 2. There's nothing wrong with that as long as it's in simplified form. Okay, if you wanted to make that 5 1/2, you can, but 11 over 2 is perfect. Let's go ahead and try one more that gives us kind of a weird answer. Let's say I have 11 plus the square root of x equals 6. Now, I need to get this 11 away from that square root. have the square root of x equals negative 5. Now, at this point, look at this. Anytime I have something that equals a negative like that, when I have the radical symbol, there's no solution. We can't get a negative because it's gonna ask us for simply the negative answer. It doesn't work that way. I know that if we put a negative 5 back in there and we squared it, we'd get 25. But anytime you get your radical to equal a negative, go ahead and automatically just give it as no solution, because it's only gonna work part of the time. So same thing if we looked at like 5b, I'm just going through your examples here. So I have x equals the square root of negative 3x minus 2. I hope you can see that. I'm gonna go ahead and change the color just so that it's a little bit lighter. Now if I square both sides, I get x squared, and then this is gonna go away. Let's go ahead. X squared plus 3x plus 2 is gonna equal 0, so I have an x there. If I do this, I can do x plus 2, x plus 1 is gonna equal 0. So this is kind of pulling from what we did last chapter. So my two solutions of x using the zero product property are gonna give me a negative 2 or a negative 1, okay? But if I have two answers for a negative 2 or negative 1, I have a negative 2 here or a negative 1, that gives me a radical that equals a negative. So again, no solution. Anytime you get it so that your radical equals a negative, it's no solution. That's the funkiest one, the craziest one, the hardest one that you're gonna get. So hopefully that helps a little bit and that you appreciated seeing my face again. So this is 11.5. You are going to be doing on pages 726 to 727 numbers. I know this is a lot, 2 through 66 even. It's a lot more than we've done the last few weeks, but you're only getting 2 lessons this week instead of the 3 or 4, okay? So good luck. I hope that you're doing well. I will talk to you soon.